And here it comes, the James Webb Space Telescope. Hello wonderful person, this is Anton, and today we're going to be discussing new observations and new discoveries coming from the iconic James Webb Space Telescope. The continuation of the series of videos where I basically explore pretty much every major discovery the telescope has made in the last few months. You can actually find some of the previous videos in the description, but today we're going to be focusing on the new stuff, new incredible pictures and media that was essentially released very recently. And let's start with this one right here, my favorite object in the solar system, well, I guess except for planet Earth. Titan, the moon of Saturn. The most interesting moon in the solar system because it's the only other object we know of, except for planet Earth, that contains things like liquid cycles, thick and active atmosphere, and even has rains and clouds. Which is exactly what the scientists were able to see recently by pointing the telescope directly at Titan. They were able to see through the very thick atmosphere, detecting various atmospheric effects such as clouds and what seems to be some kind of atmospheric haze. But unlike Earth, none of this is made out of water. These are very likely methane clouds. And that's because the liquid cycle here is mostly methane and ethane, with extremely cold conditions of something like -300 Fahrenheit or approximately -180 Celsius. But here, the nitrogen-rich atmosphere actually hides a lot of the surface, making this moon appear this way. And since the atmosphere is about 50% denser than on planet Earth, visual observations with, for example, Hubble telescope become practically impossible. But by using radar and also infrared light, it becomes possible to see through all of this. And to everyone's surprise, they found at least 2 clouds. But the thing is, clouds here are kind of rare. Previous detection of clouds was by the Cassini probe back in the early 2000s, and even here, not a lot of clouds were detected, and many disappeared very quickly afterwards. And so there is a bit of a mystery as to why Titan doesn't seem to possess as many clouds as we expect it to possess, because it does have this methane cycle that's supposed to create visible clouds. But the scientists think that they might actually have a pretty good answer. The answer being seasons. It seems to be a seasonal activity related to the part of the year, and a single year on Titan is approximately 30 Earth years. Which means that maybe Titan is actually re-entering the same season it had originally when the first clouds were seen here, and in between this, not a lot happens in the atmosphere, making a lot of the clouds invisible. Although here, not just James Webb, but also the Keck telescope, or WMKEC observatory located in Hawaii, was used to confirm the existence of these clouds. And even approximately 2 days later, the clouds were still there, but a little bit different. Which of course, first of all, confirms that these were clouds, but also suggests that maybe this was some kind of a storm-like activity with a potential rain, methane rain, somewhere in these regions. But because we have an upcoming mission that I've discussed in one of the previous videos, the Dragonfly mission, we're going to be learning more about this in approximately 10 years from now, when NASA once again lands on Titan and starts exploring this using a helicopter. Anyway, so that's the first image. Then we have something that looks like this. This might look a little bit exotic and unusual, but you've actually seen this image before. This is the reprocessed version of the SMACS J0723 image, one of the first images released by the James Webb. But in this case, it was reprocessed to show us something that was not visible originally. This is related to one of the recent videos you can find in the description about the so-called intergalactic light, also known as ICL or Intercluster light, the light coming from stars that were basically kicked out from various galaxies and are now stuck between galaxies. They obviously still produce some light, but because they're so dim, it's practically impossible to detect any of them. As a matter of fact, this light is so dim that it's approximately 50 times dimmer than the darkest spot on planet Earth, so it's very difficult to find it. But here, the scientists were able to reprocess this image, potentially discovering a lot of intercluster light in the middle of this particular galactic cluster. Mostly because many of these stars are much easier visible in the infrared light than the optical light. With the main purpose for these studies essentially being the understanding of the evolution of galaxies and the evolution of these massive clusters. And in this case, they discovered that the inner part of this particular cluster seems to be dominated by the merger of really massive galaxies. But on the outer parts of the cluster, most of the merger and interaction comes from the galaxies similar to the Milky Way. So there's definitely a bit of a difference there already. But on top of this particular intercluster light can also help us detect something else, the mysterious dark matter. Because the light coming from these stars comes from a much wider area, it becomes possible to trace the path of this light as it's bent by the dark matter located in these particular clusters. which presents a lot of opportunities for scientists to figure out how the dark matter is distributed in these clusters, and thus naturally try to understand its origin as well. But at least for now, all we get is this beautiful image. We also get a major update from the exoplanet known as WASP-39b. As I mentioned in one of the previous videos, this was always one of the main targets for the first observations of the telescope, because it has a perfect opportunity to teach us about the atmosphere of these particular planets, since it's so close to its parent star, and since it's actually relatively easy to see everything happening in this particular star system. And so just like that, we now have new updates from the recently analyzed observations. This particular planet, which is technically a hot Saturn, basically a gas giant that's extremely close to the Sun, but is not as massive as Jupiter, seems to contain quite a lot of molecules in its atmosphere, with certain molecules that were expected missing in the process. The one that was found in abundance is this one right here, sulfur dioxide, a molecule produced from chemical reactions triggered by extremely high energy light coming from the star itself. And this is an important finding because it's the first confirmation of what's known as photochemistry happening around a very different planet. The only such activity we know of is right here on planet Earth. Ozone layer, that's I guess one of the examples. Ozone layer is produced via photochemistry. When the radiation from the sun strikes the upper atmosphere, it converts some of the oxygen molecules into O3, ozone. And that is extremely important, as you probably know, to the preservation of life. Finding these types of examples of photochemistry in other star systems is one of the main goals of the telescope. Or I guess it was until now, because it just officially found it. With all of the studies related to this available in the description below. But what's really intriguing about this particular planet is of course its proximity to the star. It's about 8 times closer to its parent star than the planet Mercury. And because of this, the amount of light it receives from the star is absolutely ridiculous. Which is exactly why the photochemistry here becomes a lot more exotic than around planet Earth. It produces these sulfur dioxide clouds, but it also contains sodium, carbon dioxide, a little bit of carbon monoxide, but even water as well. Which doesn't really come as a surprise because this was originally the planet where water was found a few months ago. Although here we're talking about water vapor or molecular water, not really liquid water. But some things that were expected, such as methane and hydrogen sulfide, were completely absent from the observations. At the moment the scientists cannot explain why, but it probably does have something to do with really complex chemistry that's mostly caused by extremely powerful starlight coming from the parent star. More importantly, this of course confirms that we can now use these observations on other exciting planets, including some terrestrial planets such as the ones in the TRAPPIST-1 system. And I'm sure when the data for that comes out, it's going to be one of the most exciting announcements coming from the telescope. But at least for scientists, and at least for now, this definitively proves that James Webb Space Telescope can easily discern a lot of different molecules in even relatively distant planets. This planet right here is about 700 light years away from us, so this is technically one of the farther planets analyzed to date. In comparison, TRAPPIST-1 system is approximately 20 times closer. But we're not going to know much more about these planets until future observations. And then we have some of the new analysis and new observations, and actually one of the first peer-reviewed papers about some of the most distant galaxies discovered so far. Although in this case these were some of the most distant confirmed galaxies, there are actually several other candidates that could be even farther. And this is part of the project known as GLASS, one of the early release science projects, whose main purpose was to release as much data as possible available for a lot of scientists to peruse and to analyze, in order to make data very accessible, but to also demonstrate and test the capabilities of the James Webb. And in this case, these two particular galaxies, at the redshift of 10.5 and 12.5, might also help us solve one of the bigger mysteries in cosmology, related to the period known as the reionization period. The period during which quite a lot of activity from various stars and potentially from various galaxies and various black holes created quite a lot of super powerful light that eventually caused all of the neutral hydrogen gas that was pretty much everywhere in the universe and that didn't allow light to pass very easily to then become ionized, making the universe more transparent. Now, original assumptions like this one right here from a few years ago was that the period very likely started 400 million years after the beginning of the universe. But a lot of these recent observations and detections of these galaxies that seem to be visible from even farther away suggest otherwise. These observations suggest that the galaxies formed much faster and much earlier, but also that they were extremely active as well, indicating that these two galaxies are exceptionally bright and existed 300 and 400 million years after the Big Bang. And that extreme brightness is really important in helping us understand reionization. It's very likely what caused the universe to change so much, but why exactly these galaxies are so bright is a question we cannot answer. But it seems that even the stars themselves are potentially brighter than a lot of the stars we have now, or at least overall produce a lot more energy. And that of course is really exciting because, in theory, this could be the first detection of the so-called population 3 stars. The first stars in the universe created from all of the early hydrogen that was pretty much everywhere, that very likely existed for just a few million years before exploding, producing other elements, and thus leading to the production of other stars. We've never really seen these stars, but the scientific community has always been looking for them. Now, maybe these population 3 stars, these early stars, is the main reason why these galaxies are so bright. But in reality, right now, nobody really knows. What is clear though is that galaxies definitely existed much earlier than we thought, with the stars very likely forming much quicker and much earlier as well. And as previously mentioned in another video, it does not negate the Big Bang theory at all, it actually kind of reinforces it, but it does kind of present a new problem with trying to figure out why exactly so many galaxies and so many stars formed so quickly. And because these galaxies were confirmed to be very compact, and also seem to have stars that are mostly made out of hydrogen and helium, this being galaxies filled with population 3 stars, right now is one of the better explanations. But on top of all of these observations, we also had a few updates in regards to how the scientists and the engineers are now planning to protect James Webb from future potential micrometeorite collisions. As you probably remember, there was a major collision in this region right here, which was discovered to be a statistical anomaly and quite unlikely, but happened nevertheless. And to date, at least 13 other micrometeoroids hit the primary mirrors, affecting them just a little bit, but not enough to be a concern. As a matter of fact, all of this was pre-calculated and predetermined, and even now the telescope is still operating at least twice its expected accuracy. But nevertheless, it means that at least 2 micrometeoroids are going to be hitting the telescope every single month. And so to try to prevent this and to try to protect the telescope from basically even further damage, the scientists think that future observations are going to try to face away from what's known as the micrometeoroid avoidance zone. Or essentially, they're going to be facing the telescope away from the area where most of the meteoroid collisions occur. This area is technically defined as a kind of a cone, but certain regions around this cone have much higher frequency of collisions than other regions. And so by limiting the exposure to those particular regions, the number of collisions will probably decrease dramatically. But even if they don't, it's still going to take years and years of collisions before the telescope becomes relatively inaccurate. As a matter of fact, it was designed to sustain 10 years of these collisions, so in that sense we still have some time. And so that's pretty much the major discoveries and major announcements in regards to the telescope as of today, as of early December 2022. I'm sure there will be more announcements later on, but usually around Christmas time not a lot of observations are made because of the holidays. Nevertheless, we'll definitely have more videos before the end of the year, and if you do enjoy these and if you actually want to learn more about what James Webb discovered, make sure to subscribe, maybe share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, maybe support this channel on Patreon by joining a channel membership or by buying the Wonderful Person t-shirt that features James Webb Telescope as well. Stay wonderful, I'll see you tomorrow, and as always, bye bye.